Welcome back. Welcome to the 28th lecture of Digital Electronics subject. In lecture number 27, we have dealt with standard SOP form. We have dealt with the sum of products form, product of sums form, truth table form, and standard sum of product form. So in this lecture, we will be dealing with the standard product of sums form, Venn diagram form, as well as karma map form. Okay. So before going into standard product of sums form, we need to discuss something more about standard sum of products form. So coming to sum of products form, standard sum of products form. See here, in the example which I have dealt with, that is function f of ABC is given by a bar b or b bar c. Now see, in the first term c is absent, and then the second term a is absent. So we are adding c or c bar. C or c bar is equal to 1, as well as a or a bar is equal to 1. Taking these two golden rules into consideration, we have taken a bar b and c or c bar, or b bar c and a or a bar, and you got the standard SOP form. So why it becomes a standard SOP form? All the terms contains all the variables given in the function. See here, all the terms contains all the variables a, b, and c. Such a form is known as standard SOP form. Okay. So let me take this example once more. Then after that we can go into a POS form. Let me take the same example into the truth table form, and then we will deal with standard POS form. Okay. So coming to this lecture, so here we will deal with first one is we will go with standard sum of products form. After that we will go with standard POS form. Okay. So the function what we are having is f of a comma b comma c is a bar b or b bar c. So in the first term c is absent, and in the second term a is absent. So this can be written as a bar b or a bar b and c or c bar, or b bar c and a or a bar. Now expand. So what we get is a bar bc or a bar bc bar, or a b bar c or a bar b bar c. So this form is known as the standard SOP form. Okay. Now let me draw the truth table of this function. Okay, so function is f is given by a bar b or b bar c. Let me draw the truth table first. So I am having three inputs. Here I am writing a bar b, then b bar c. Now f. So here I am having inputs as a, b, and c. 0, 0, 1. Sorry, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 0, and last one is 1, 1, 1. Okay. Now coming to a bar b. A bar is you should take the complement of each term. So 1 dot 0. 1 dot 0 becomes 0. Here 1 dot 0, 0. 1 dot 1, 1. 1 dot 1, 1. 0 dot 0, 0. 0 dot 0, 0. 0 dot 1, 0. 0 dot 1. That becomes 0. Now coming into b bar c. B bar c means you have to take the complement of b and with c. So 1 dot 0. 1 dot 0 means 0. 1 dot 1, 1. 0 dot 0, 0. 0 dot 1. 0 dot 1 is 0. 1 dot 0, 0. 1 dot 0, 0. Sorry, 1 dot 1, that is 1. So that is a mistake over there. That is, here we have b bar c, right? So that is, what is b bar? 1. 1 dot 1. 1 dot 1 is 0. Now b bar is 0. 0 dot 0. 0. 0 dot 1. 0. Now what is f? You add these two. That means you OR these two. 0 or 0. 0. 0 or 1. 1. 1 or 0. 1. 1 or 0. 1. 0 or 0. 0. 0 or 0. 0. 0 or 0. 0. 0 or 0. 0. So this is the resulting function. Okay. Now if you are going into one second, that is b bar c. B bar c, you will get 1.0. B bar c. Okay. Only 3 terms are there. Let me check. A bar b 1.00, 1.00, 1.11, 1.11. Here you will get these terms are 0. So you will get 0. Yeah. Now b bar c, that is here you get 1.00, 1.11, 0.00, 0.10, 1.00. Here you will get 1.1. Yeah, that is here you will get b bar, that is 1.1. 1.1, here it is 1. Okay, that is a mistake over there. B bar c, that is 1.1. 1.1 you will get it as 1. Yeah. So function you will get here it as here you will get 1. Okay. Now how do you write f? If you need to write f, take ones. So here what did you get? A bar, b bar, c. A bar, b bar, c. Or that means this is taken. Second one is or a bar, b, c bar. And you will get this one. Or a bar, b, c bar. Then take this one. Or a bar, b, c. A bar, b, c. Or this one. That is a b bar, c. A, b bar, c. Now if you are comparing f and these terms, how can I write it? If I am comparing this one, see a bar b bar c. A bar b bar c is already here. Now next one is a bar b c bar. A bar b c bar is already here. Then a bar b c. A bar b c is also here. Then a b bar c. A b bar c is here. Okay. So here, standard SOP form means each term is designated as 1. That means if you are having a bar b bar c, the f will be 1 there. Okay. Now take the 0 terms. Now coming into standard, now I have formed the standard SOP form from the truth table. Okay. Now from the truth table itself we can form the standard POS form. So how to form the standard POS form? Take zeros. Okay. So take zeros here. So I am going to take zeros. So this is by taking ones. By taking ones of f, I am getting and by taking sum of products form, I am getting standard sum of products form. Okay, that is this one. Now how to write the standard POS form of this function? Okay, take zeros and give the OR format. So here this is the first 0. So what is there? You are having a is 0, b is 0 and c is 0. So you can write f is equal to, here you no need to write, so here 0 is not bar. So you can write a or b or c. And where is the next 0? That is here. That is you will get a bar or b or c. A bar or b or c. And S0 here. That is a bar or b bar or c. A bar or b bar or c. Next one is this one, 0. That is a bar or b bar or c bar. A bar or b bar or c bar. Okay. Now how will I write this? What is a or b or c? What is a or b or c? That is, this is 0. Yeah. 1, 2, 3, 4, 5, 6 and 7. What is a or b or c? That is 0. Yeah. What is this is 0. Then what is a bar or b or c? A bar or b or c is 4. So you are having 0 is there. This term becomes 4. Then a bar or b bar or c. A bar or b bar or c. That is this one. You are having 6. So this becomes 6. Then a bar or b bar or c bar. That is 7. Okay. So and write it in ascending order. So you will get pi m of 0, 4, 6, 7. That gives the standard POS form. Now each term in standard POS, each term in standard POS form is known as match term. Okay, why is known as match term? For match term, the value becomes 0, whereas for min term, that is for SOP form or standard SOP form, the value becomes 1. Okay, that means if the value of f becomes 1, then it is standard SOP form, and the corresponding terms is known as min term, whereas this is, so here we are having min terms, and whereas if the corresponding value is 0, if the corresponding value of f is 0, and you are having odd terms, then that is known as standard POS form, or the terms in that is known as match terms. Hope you have understood how to find the standard SOP form and standard POS form. Okay, so the first part of this lecture is standard POS form. I have formed the standard SOP form. Then from the standard SOP form, I have formed the standard POS form. Okay. So one more example, I will show you how to form the standard POS form using truth table. That will be easy for you to understand. So coming into second question. Okay, form the standard POS form. Okay. Standard POS form is, you can write it as say f is equal to, or you can write f of a comma b comma c. F of a comma b comma c is a bar or b bar and a or b. Okay. So here the easy way is step 1 is first formulate SOP form. Second step is form the truth table. And then from there you form the standard POS form. That is the most easy track. Okay. Now, coming to f is equal to, you expand it, you will get a bar dot a or a bar dot b or a b bar or b b bar. A dot a bar is 0, similarly b dot b bar is 0. So you will get what? You will get a bar b or a b bar. Okay. So the input function is having 3 variables. So in both the terms, c is not there. Therefore, we can write f is equal to a bar b and c or c bar, or a b bar and c or c bar. So that is a bar bc or a bar bz bar or a b bar c or a b bar c bar. Okay. So how to write the corresponding terms here? This is 0 1 1. This is 0 1 0. This is 1 0 1. This is 1 0 0. Okay. What is 0 1 1? 0 1 1 is 3. 0 1 0 is 2. 1 0 1 is 5. This is 4. Yeah. Okay. So you can write f as sigma. That means in terms of min term, f is equal to sigma m 2 4. Sorry, 2 4 2 3 is there. 2 3 4 5. This 2 3 4 5. You should write in ascending order. Okay. Now let me find out the this is min term, right? This is min term. That means now I have formed which form? This is form, that is I have formed the standard SOP form. This is the standard SOP form, standard sum of products form. Now let me draw the truth table of this one, that is a bar b or a b bar. Okay, along with the c. Okay, or I will draw the truth table of the standard SOP form. That is a good way. So we can write f is equal to a bar bc or a bar bc or a bar bc bar or a bar bc bar or a b bar c, a b bar c or a b bar c bar or a b bar c bar. Okay. So now I am drawing the truth table. I am writing f directly because I have the easy way to write f. So these are the inputs. This is the output. So I am having A, B, C. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Yeah. So to get F, F is therefore 2, 2, 3, 4, and 5, right? So this is 0, or if you are taking the decimal equivalent, it is 0, 1, 2, 3, 4, 5, 6, 7. That is the decimal equivalent. So for 2, 3, 4, 5, it is 1. For 2, 1, 3, 1, 4, 1, and 5, 1. Okay. Because that I have got from the minterm expression. All other terms will be 0. So 0, 0, 0, 0. Okay. So wherever you are getting the values as 0, wherever you are getting the values as 0, you write it in OR form. That is all. So here you are getting the 0. So here the match term, you can write it as A or B or C. Second term, what is it? That is, see here, 0 becomes without bar. So you can write it as, this one is A or B or C bar. That is the second one. Here you will get 0. What is it? That is A bar or B bar or C. That is 1, 1 and 0. Now this is also 0. So again you will get A bar or B bar or C bar. Therefore the function in standard POS form, you can write it as A or B or C, A or B or C, and A or B or C bar, and A bar or B bar or C, and A bar or B bar or C bar. Okay. So if you are simplifying it, you can write it as pi m, which comes out of 0, 1, 6, 7. Pi m 0, 1, 6, 7. Okay. Or we can write in general form as that is equal to m0, capital M0, m1, m6, m7 dot, m0 dot, m1 dot, m6 dot, m7. Okay. So this case I can write it as, this one. This I can write it as m0 dot, m4 dot, m6 dot, m7. Okay. So this is a representation of standard POS form. Okay. So hope you have understood how to form the standard POS form. Okay. So the easy way is by using the truth table form. Okay. So what is a match term? So in case match term means the values of f for which the function becomes 0. Okay. The values of f for which the function becomes 0 is known as match term. Okay. The values of f for which the function becomes 0 is known as match term, whereas the values of f for which the function becomes 1 is known as mean term. Okay. The values of f for which the or when f is equal to 0, the corresponding terms are known as match terms, and when f is equal to 1, the corresponding terms in concerned terms in the function is known as mean terms. Hope you understood the concept of min term, max term, and standard SOP form and standard POS form. Okay. Now coming into next part of the lecture. Okay. So in the last lecture we are dealing with what? So sum of products form, product of sums form, truth table form is over. But here we have taken the truth table form to find this standard product of sums form, that is known as conjunctive canonical form. Standard product of sums is also known as conjunctive canonical form, CCF. And standard sum of products form is also known as disjunctive canonical form, that is DCF. Now coming into Venn diagram form. Okay. So Venn diagram is an easy way of representing a function. Okay. So coming into Venn diagram form, that is the fifth one. So this is the fifth one, standard POS form. So coming into the sixth one, that is Venn diagram form. Venn diagram form. Yeah. See, suppose I will take an example. See, if f is equal to A bar B or B bar C. Okay. So here there are three variables A, B and C. Okay. So I am drawing the Venn diagram. Okay. The set A is here, set B is here, and set C is here. Okay. So what I have to take is A bar B. That means this is A, B and C. Here which all comes A bar B. That means what is not in A but in B. Yeah. So what is not in A but in B. That means here you have to take this much part. What is not in A but in B. So you have to take this part. Yeah. Yeah, that is that. What is not in A but in B. Then B bar C. That means here what you have to take. What is not in B but in C. Okay, what is not in but here this area you cannot take because that comes with A bar. What is not in B but in C. That means we have to take this part. We can take this part. Okay. Okay. Now so which parts are excluded? The excluded parts I will draw with another color. This is these the areas marked X are excluded. Okay. So this is an example of Venn diagram form. Okay. So F is equal to A bar B or B bar C means A bar B means not in A but in B. Okay. Then B bar C means you have to assign the conditions accordingly. Okay. So that is the basic example of Venn diagram form. Okay. So but Venn diagram form is not generally used. Okay, because it is a very basic graphical type representation. And generally Venn diagram forms are generally not used. Okay. Okay. But it is we will be following Boolean laws, Boolean algebra, and the next type of representation that is known as Karnaugh map or standard SOP form or standard POS form. Okay. So coming into Karnaugh map. Okay. So next part is seventh one is representation of these Boolean functions using Karnaugh map. Using Karnaugh map, that is known as K map. Okay. So what is basically K map? So if you are having a K map, it is a simplified truth table. So you say it is simplified truth table. Second one is all the inputs and outputs can be tracked directly. Okay. Because here there is no differentiation for inputs and outputs. Everything is embedded onto the table. Third one, SOP expressions. Okay, that means SOP or standard SOP, or you can have product of sum or standard product of sum expressions can be taken directly from this table, directly from K-map or Karnaugh map. So these are the basic three advantages of this Karnaugh map. Okay. Then another advantage is this Karnaugh map can be used for the minimization of Boolean expressions. Okay. Minimization of Boolean expressions. That means without accounting for the Boolean laws, this Karnaugh map gives a track to how to reduce this Boolean expressions. Okay. So here in the next lecture onwards, in the next lecture we will deal with basically three types of K-maps. First one is two variable K-map, three variable K-map, as well as four variable K-map. Okay. So these three types of K-maps we will deal with in the next lecture, along with the min terms and max terms. That is basically standard SOP and standard POS forms that can be formed using this Karnaugh map. Okay, so this was an introduction to Karnaugh map. So in the next lecture we will deal with this 2 variable, 3 variable and 4 variable Karnaugh maps in detail. Okay, so next lecture is entirely devoted for this Karnaugh map only, for and formation of Karnaugh map. Okay, there are 5 variable Karnaugh map, 6 variable Karnaugh map, etc. But in the scope of syllabus, in the scope of the syllabus, that is only up to 4 variable K-map. Okay. So to sum up this lecture, we have done with the standard POS form. Okay, that means first you have formed the standard SOP form, return the truth table, and from the truth table, if the value of the function, if f is if f is equal to 1, we have taken it as min term, whereas if f is equal to 0, we have taken it as match term. Okay, match term is basically in OR format. Okay, that means ANDing the OR formats, whereas POS this one SOP form is ORing the AND formats. Okay, so that is basically standard POS and standard SOP forms, and we have discussed about min terms and match terms, and we have a small description of this Venn diagram form of representation and an introduction to K-map. Okay, so hereafter we will be dealing with K-map because the reduction of expressions is very easy using Karnaugh map. And after this Karnaugh map, we will deal with formation of this reduction of these expressions using Karnaugh map, as well as after that we will go with AND or invert logic. That means if an expression is given, how to generate a logic circuit using Karnaugh map. Thank you.